All right, guys. I think question one is not difficult. I mean, you shouldn't have problems doing it, right? So let me show you. If you haven't done question one, let me show you how to do it. Sorry. All right. Can you see it from the back seat? Is it too small or too large? It's fine, right? Okay. Now you should take the product of this, guys. You get this, right? This is the likelihood function of theta. Now the second step is to take the log of the likelihood. So you take the log of L theta. So it becomes n log of theta plus theta minus 1 times the sum of the logs. Okay? Now it's really important that you know how to simplify products and take logs. To help you with this, I posted on my website, on the course website, some elementary operations on taking products of functions and logs of products of functions. So please have a look at it if you have problems. Alright, the next step is to take the derivative with respect to theta. In this case we only have one parameter, so the derivative is this. Okay, set this to 0, you get the solution that theta hat, the solution of this equation, equal to minus n right. This is the solution. Now to make sure that this corresponds to an MLE, you need to look at the second order derivative. You only need to do this when you have the parameter theta is a scalar. In other words, you have only one parameter to estimate. So in such cases, you need to show, you must show that the second order derivative is negative, right? In this case, it is minus n by, which is indeed a negative number, right? Hence, it's an MLE. All right, is this clear, guys? I mean, you shouldn't have difficulties doing these questions, guys. It's pretty standard approach, right? Write the likelihood, take the log, take the derivative, set to 0, solve, and finally show that the second order derivative is negative. Okay? Any questions? All right, can you do the next question, guys? Question 2, please. All right, guys. Let's see how we can do. You guys done question 2 yet or no? Some of you have done. All right. Okay, let me show you how to do it if you haven't done it. So this is so this likelihood is the product of the density functions, and this simplifies to this. The next step is to take the log of the likelihood. Right, and the next step is to take the derivative with respect to theta. Theta is the only parameter. So you get 2n by theta minus the sum of xi. Set this to 0, guys. You get the solution that theta hat equal to 2n by sum of xi, which can also be written as 2 divided by x bar. X bar is the sample mean, guys, right? Now, to show that this is indeed an MLE, you need to do the second order derivative. Which is minus 2n by theta squared, which is a negative number all the time. Hence, theta hat is an MLE, right? So it's again it's as easy as the first question, question number 1, right? Yes. Yeah. It's not n. I think this is why you, because this is why you need to get the manipulations correct. You know? Yeah. I mean. Just a minute. Yeah, we have a question. Yeah. Well, yeah, you need to find the probability that x is less than 0 first. Try to express that in terms of mu, and then find the probability of mu. Mu is the solution. Yeah, think about it. Just try. The first thing you do is express the probability. X maximum. No, you shouldn't think like that. You should think like try to express the probability that x less than 0 in terms of mu. And then find the MLE for mu. The thing about it, just give me a second. Look here, I think what you're trying to do is here. When you have c times xi, where c is a constant, this is the same as c times the sum of xi, I from 1 to n. Okay, this is the rule. Okay, where c is
but if we because this sum, it should
Yeah, huh?
Would you just yell in your echo? Then once you've got
Okay.
your hand up,
Okay.
understand? You just work out probably to your
Are you okay?
Yeah.
Yeah, just try to visualize. I mean, what you need to do first is to express the probability in terms of mean. And then the second step is to find the only for mu. And hence the only for as well.
Yes.
Okay, sir. Are you guys having problems with question 3? I see some of you are having problems. Let me show you how to do it. This is question 3, guys. You have a variable x that has the normal distribution, and the question is to find the MLE of the probability that x is less than 0. So the first thing you should do, guys, is to find the probability that x is less than 0. Right? I'm going to show you how to do that. All right. So this is the probability that a normal variable with these parameters is less than 0. You might have done this in your first year. Now, what I'm going to do here is I'm going to standardize both sides. You know what standardization is, right? Standardize means that you make this into a standard normal variable. And the only way you can do that is to you see what I've done? I have subtracted mu on the left and the right. Okay? So the left-hand side will become the standard normal variable, that is 0 mean and variance 1. Now we know that this probability is simply phi at minus mu, where phi is the CDF of M01. Okay? So this is the first thing you should do, is to express the probability of interest as a function of mu. Mu is the only parameter in this question, guys. Right? All right. The second thing to do is to ask the question: what is the MLE? What is the MLE of the probability that x is less than 0? And this, because of this relation, it's the same as the right, because this is equal to this, guys. The MLE of the probability is equal to phi at minus the MLE of mu. Yeah. I mean, this is the invariance property. I think it's in the lecture notes, but I didn't say that explicitly. But this is known as the invariance property of MLEs. Yeah, which is part of the notes. Now, if you guys remember from about a week or so ago, I worked out in one of the lectures. If you have a sample from a normal distribution with parameter mu, then the MLE for mu is, do you guys remember what it was? The MLE for mu is x bar, right? Do you guys remember this? I think it's one of the examples I worked out in the lectures, guys. So if you look back in the scan notes from the lectures online, you will see this, that I proved in one of the examples that the MLE for mu, when you have a sample from a normal distribution, the MLE for mu is the sample mean, that is x bar, right? All right, so what you need to compute is x bar here, guys. So to compute x bar, you just use the numbers. You see, you're given a set of numbers. Need the glasses now. You're given a set of numbers in the question, guys. So x bar will be 1.466 plus 1.791 plus minus 0.237 divided by 8. Okay. Okay, and you can work this out. If you have a calculator with you, this will give you a number, right? And then you sub this into here, you get the MLE for the probability. Okay, so you just work this out, sub in here, and you get the answer. All right, guys. Is that clear? No? Are you guys okay with that? Yeah. What about you, sir? You okay?
Yeah, I'm fine. I'm just trying to
Okay. Yeah, but yeah, I was just make an announcement, because just make an announcement, guys. Just the next 4 questions. That is 4. The next 4 questions are these are for next week, guys, because the reason I'm doing this is because, I mean, it doesn't stop you doing it this week if you have already done the others. I mean, but I would like to do these 4 questions for the exam classes next week. But what I'm going to do in the remaining time is you may remember from last sheet number 3, this is sheet 4. In sheet number 3, I did not do certain questions. You guys were here last week, right? So I'm gonna do those 2 questions. I'm gonna do the questions that I did not do last week. So that's what I'm gonna do in the remaining time. We have about half an hour left. Okay, so let me start with. Are you guys okay with this? Once again, are you okay with this? Okay, so let me start with. There were, I think there were in particular 2 questions I did not do. All right. One was question 6 and the other one was question 7. Question 6 was the following: that there are, you should remember, I don't know whether you have sheet 3 in front of you or not, but you should remember question 6. There it says there are n observations from a binomial variable with parameters 2 and p. A binomial variable with these parameters has the this as the probability mass function, right? I'm sure you guys know this is the PMF of the binomial, guys, right? And when you have to choose x can only be 0, 1, or 2. There are only 3 possible values, right? So for example, the probability that x equal to 0 is to choose 0. Yeah, and the probability that x equal to 1 is and the probability that x equal to 2 is this. All right, so there are 3 possible values for each x: 0, 1, or 2, and these are the corresponding probabilities. You are also told in that question, if you look at the question, guys, that the question says that there are little, this is small n, guys, small n, there are little n0 observations taking the value 0, and it also says that there are little n1 observations taking the value x equal to 1, and there are little n2 observations taking the value x equal to 2. And in total, the number of observations, which is n0 plus n1 plus n2, is equal to capital N. All right? This is what the question told you. You should, I'm sure, I don't have the sheet in front of me, but if you have the sheet number 3 in front of you, this is what you will see. All right? You have a total capital N observations. Right? Each observation is a binomial 2p, 2 comma p. And there are n0 of them taking the value x equal to 0, and 1 of them taking the value x equal to 1, and n2 of them taking the value x equal to 2. Now the question was to find the MLE of p. To find the MLE, the first thing you need to do is to write down the likelihood function, guys. Okay. So the likelihood function, the basic blocks are these ones. These are the 3 basic blocks, guys. Now, this is the probability that a single x is equal to 0. But we have not just a single one, we have n0 of them. So so the corresponding probability is this, that you need to power it to n0, right? Similarly, this is the probability that a single x equal to 1. But we have not just one x equal to 1, but we have n1 x equal to 1, right? So the corresponding probability is this. And similarly for this. This is clear, guys. And so the product of these 3 terms is the likelihood. Can you see that, guys, or no? Yes or no? Because you have n0 observations taking the value x equal to 0, and this is the probability that a single x equal to 0. So if you have n0, the corresponding probability is to the power n0, and similarly to the power n1, and similarly this to the power n2, right? Now this one obviously you can simplify, guys. Right, it simplifies to this, and this can be further simplified as this one. All right, so this is the likelihood function. The next step is to take the log of the likelihood, which will be n1 log 2 okay. And the next thing is to, in order to find the MLE, you need to find the derivative with respect to p. So I'm going to differentiate the log of the likelihood with respect to p. So you get this. You set this to 0 and solve for p. You will get p hat equal to this. So there's a 2m. Okay, equal to this. Okay. Now finally, to show that this is an MLE, you need to find the second order derivative, which is this. This is the second order derivative, and you have a minus here and a minus here, so the term must be negative number, right? Hence p hat is an MLE. Okay. Is that too small, guys, or can you read it from there? You okay? All right. So it says, and I know this was a tricky question last week, guys. That's why I've done this today, because it was, I think several of you had problems doing this last week. So that's why I did this now. Okay. Is this clear to you now? Or not yet? Huh? You alright, guys? Yeah, good. All right. I also want to do the next question. This is question 6. I think the last question from sheet 3 was question 7. I will do it right now in a minute. So if this is clear, I will take it off, guys. This is question 7, guys. I think it was about x is a variable. The variable x was the number of cereal boxes bought by men, and p is the probability that P is the probability that a cereal box was bought or purchased by a man. Clearly, the total number of purchases, was equal to 70, right? So clearly X has a binomial distribution with parameters 70 and P. I mean, this is a simple example of a binomial distribution. You have 70 purchases, right? And out of that, certain number are bought by men, and the remaining are bought by women, right? And P is the probability that a cereal box was bought by a man. So clearly, X is a binomial variable. Yeah. X is a binomial variable with parameters 70 and P. I think the first part of the question was to write down the first part of the question was to write down the likelihood function. Is to write down the likelihood function if the number of purchases by men is equal to 58. So if 58 men bought the box, cereal box, then the corresponding probability is 70 choose 58, P 58, 1 minus P 12. Alright? So this is the likelihood function for P if 58 men bought the cereal box. Yeah? The second part of the question, if I remember correctly, was to find the MLE for P. Now to find the MLE for P, you just follow the standard procedure, guys. You take the log of the likelihood, okay, and then you differentiate the log likelihood with respect to P. Set this to 0, right, and solve for P. If you solve this equation for P, guys, you will get P hat equal to 58 by 70, right? And finally, to make sure that this is an MLE, you need to do the second order derivative. Which is this, right? And since you have a negative and a negative, this must be a negative number, right? Hence, alright, I mean, this is pretty straightforward, guys. Yeah. Okay, so the MLE for P is 58 by 70, guys. Now that's the second part. Now the last part of the question, if you guys remember what it was, the part 3 of the question is what is the MLE if P lies between a half and 2/3. I think this was the question, guys. Now to do this, how do we do this, guys? Do you remember what I taught you in the class, in the lectures? How would you do this question, guys?
Restricted domain?
Yeah, restricted domain approach, guys. Do you guys remember one of the approaches I talked about in the lectures, guys? It's known as the restricted domain approach. So that's what I'm going to do here, guys. So let me take this off here. So this is part 3. So what I'm going to do is I'm going to describe to you how to deal with what you need to do, guys, is you need to plot L of P. L of P is the likelihood function of P versus P, right? Now suppose this is 0, suppose this is 1. So if this is 0, if this is 1, then the half is around here somewhere, right? And 2/3 will be, I guess it will be here, and 58 by 70 could be here somewhere. Now how do you think the graph will look like? If I mean, this is another thing. I mean, I must tell you guys. I think I mentioned this yesterday, guys, in the lectures. Graphing of function is something that's required for this course, but I don't have the time to teach that because that's not my. I mean, it's something you should have. You should have learned in Calculus 1. But if you have difficulties with graphing of functions, I'm most happy to help you outside the lecturing hours. Yeah. You can come to my office anytime. I'm prepared to help you with graphing of functions. But as far as teaching during lectures or during example classes, I expect you to graph functions by yourself, right? I expect you to be able to graph functions. If you have difficulties, you can see me outside hours, right? So in this case, guys, what I like you to do is to graph this function here. This is L of P versus P, and you should do that in the correct way. It will look something like this. Okay, it will look can you, is it too light or? It will look something like this, okay? The graph will look like this, and this is the largest point. Now, what we want to find is we want to find the MLE of P if P is between half and 2/3. In other words, between these 2 points, or between these 2 points, right? So we want to find the maximum likelihood estimator. In other words, the largest point of the graph, what it corresponds to if P is between half and 2/3. Now, between these 2 points, what you have here is an increasing function. It increases from this point to this point. So the largest point is this one, and hence the MLE for P is 2/3. So that's the is that clear, guys, or not? You can see that between half and 2/3 you have an increasing function. So the largest point of the graph between those 2 points is at P equal to 2/3. Alright, so it is the MLE. Yeah. Alright, so this is the last question I did not do last week. Right. Now next week, you don't need to wait till next week, guys. Next week I will do these 4 questions from sheet 4. That is question 4, question 5, 6, and 7. Right. But if you have time before that, just try to do it. Alright. Because
你要回去了吗？现在回家吗？哦，回那么早，我都回家回那么早。啊？什么考试啊？看电视啊。
There are n0 access equal to 0, n1 access equal to 1, and n2 access equal to 2. Yeah.
Only 12.